Hi everyone, thanks for joining our rainy day training for the emergency response and reporting system. Picture tonight's drive. It'll be heavy rain, low traction, poor visibility, noisy cabins. These are exactly the moments when a system earns its keep. In the next 20 minutes, our team will show how we first collect live telemetry, second, detect incidents in real time, third, alert responders automatically, and last but not least, let passengers trigger help with a single tap, no menus, no friction. So it's easy for them to just make an alert so they don't have to figure it out how to do it. It's so easy. Like imagine you're in an accident, you're just figuring how to do that. No, it's just simple, easy, single tap. So what you are looking at, this is a live system. The backend is fast API and the root path is a passenger web page. Under the hood, a telemetry simulator streams realistic signals from multiple autonomous vehicles. We store data in SQLite, detect incidents using transparent rules, and notify responders via webhook with a reliable outbox fallback if the webhook is down. So the promise is, if there's a crash on a danger stop, we detect it, record it for audit, and notify responders immediately. And if a passenger feels unsafe, they can send a manual emergency alert in one tap. So the big picture is, think of the flow as four steps. Data in, which leads to decision, which leads to record, which leads to notify. So data in, vehicle telemetry plus passenger input, decision, rule engine evaluates patterns, record, we persist incidents for audit and analysis, notify, we push a concise, structured alert to responders. So what will be the system architecture? Let me walk you through the architecture in simple terms. Front end, passenger page, a clean page with single emergency button, manual alert form, location severity notes, designed for low light, wet screen, shaky hand scenarios. Live incident feed on the right side, auto updating list of detected and manual incidents. Second, each item shows time, vehicle, rule triggered, and status. So telemetry simulator streams position, latitude, longitude, speed, acceleration, impact g-force, microphone loudness, which can be determined to dB decibel, airbag status, rollover flag, and traction events into the backend. Multiple vehicles, realistic error, and correlation in the signals. So what our fast API do in the backend? Ingest telemetry and manual alerts, rule engine evaluates sliding windows of recent data, persistent SQLite for vehicle telemetry, incidents, and manual alerts. Notify strikes webhook first, on failure writes a local outbox log for guaranteed delivery. So why, like there might be a question in your head, like why SQLite? First, it's slide based, and second is file based, and there are like zero problems in that. It's perfect for training, demo rig, and surprisingly robust for audit trails. So how detection works? Let me explain that in a simple language. Our rule engine prioritizes clarity over black box complexity. Each alert ties to a specific named rule so investigators can see the why immediately. The the key rules are airbag deployed. If the airbag flag flips true, incident airbag deployed. High impact. Impact is greater than equal to 2.5 G. Rain tune. Incident equal to high impact. Extreme deceleration plus speed drop, which means hard brake. No motion plus loud cabin if speed is less than 5 km per hour for more than or equal to second, and mic is greater than or equal to 85 decibels. Incident is like stop loud cabin. Rollover flag. Similar sets a rollover boolean. If true incident, then it means like if it's true, it means incident is rollover. So what we can expect, the three anchors of this model: reliability, explainability, and usability. So reliability means if the responder webhook is down, we do not drop alerts. The payload is queued in an outbox and in a file backlog. A small worker retries with the backup until it succeeds. Explainability. Every incident includes a rule label and the key metrics that exceeded thresholds. No guesswork. Usability. Passengers can single tap panic action. The form is optional. If they can't type, the location plus time plus request will go out immediately. So speaking of that, how a live demo worked, like my partners will show you how it works, like how we made it and how it works, but just giving you a small situation how it works. Like Like we saw the simulator for multiple vehicles, induce a rain scenario, threshold already rain tune, watch the first automatic instant landing the feed, flip the responder webhook off briefly to show outbox fallback, then on again to show automatic catch up. Submit a manual alert like a nervous passenger during a storm. So this is how the demo can go into. While we run it, listen for reliability, outbox catches outages, explainability, every instance says which rule and why, usability, the panic action is immediate and hard to mess up. So, enough of chit chat from me. In a moment, Palvi will drive the live demo, start the simulator, trigger a scenario, and file a manual alert. Then Shihana will show exactly where responders receives and how we confirm delivery. Finally, Unimai will walk through the records we keep and how we review them after the storm. That's our roadmap. Let's see in action. Thank you.
Hi everyone, I am Pallavi and today I am going to walk you through the exact flow as if you're watching it on screen. So we'll walk the same path the system takes, what the car senses and what the backend does and what shows up for responders. So you can picture each step in your head. Heavy rain, slick roads, noisy cabins. This is where our system earns its keep. Today, I'll cover two parts that work together: automatic detection from telemetry and manual passenger alerts when a human says something's wrong. The rainy night mental picture. Imagine it's 11:30 p.m. The rain is hammering the windshield, wipers on max. The vehicles is part of our small fleet. The telemetry simulator is feeding the backend a steady stream of signals: speed, acceleration, impact force, cabin noise, airbag, flags, GPS, and a few health and environment indicators. Because rain increases risk, we expect more sudden braking and a bit of chaos in sensor readings. Our rules engine is listening from patterns like rapid deceleration, elevated cabin noise, and especially airbag deployment combined with impact force spikes. When those align, the system upgrades this event from a pre crash state to a likely collision. Automatic, automatic detection when actually fires. What actually fires? Let's narrate one event. The vehicle hits a slick path. The longitudinal acceleration plunges, hard brake. Cabin noise jumps, you heard the thud of a hit and passenger shout. Impact force crosses our threshold, the airbag flag flips to true. That combination trips our collision rule. Instantly, the backend creates an incident record. Think of it as a durable card in our database with timestamp, vehicle ID, approximate GPS, and the type of the collision of the airbag or severity, example critical, mild, serious, channel, auto, a compact evidence summary which signals fired, peak values, and a unique incident ID for audit. Right away, the incident goes through our notify pipeline, webhook to responders, or if that path is offline, a log out box for guaranteed delivery later. No screens needed. You can imagine an entry stamped auto slash critical appearing in the right hand live incidents list. Why the record matters and how we avoid spam. That record isn't just for the UI, it's the backbone for audit, analytics, and follow up. We'd rather create one clear incident than spam responders with duplicates. So we do deduplication within a small time window. If multiple packets save the same event is going on, we update the existing incident rather than creating five new ones. All updates append to a tamper evident trail: who or what changed, severity, when notifications fired, whether the webhook acknowledged the receipt. We also rate limit how often we ping responders for a single incident, and we support automatic retires with back off if their endpoint is momentarily unreachable. Heavy storms often stress network. We plan for flakiness. Two scenarios, same pipeline. Scenario A: sensor confirmed crash. Scenario B: passenger reported emergency. Auto incident appears in a sensor confirmed crash. Collision airbag severity is critical, channeling to auto. Responders see evidence airbag true impact force, high deceleration, steep confidence is high. Passenger reported emergency, passenger reported report appear incident appears as passenger reported, severity major slash critical depending on selection channel manual. The note may say medical emergency or unsafe driver nearby or vehicle stopped in floodwater. Even if sensors are ambiguous, humans can escalate and the responders still get a precise timestamped record with coordinates. Either way, the pipeline is the same: ingest, detect if auto, record, notify, and audit. We minimize the chance of a silent failure in bad weather by letting both machines and humans speak up. Security and privacy design. We collect only what we need to help people quickly: time, vehicle ID, rough location, incident type, severity, minimal evidence, and etc. Sensitive fields are encrypted in transit and at rest. Access is role based, and we enforce data retention limits so incidents don't live forever. Manual notes are plain language but scrubbed for obvious PII beyond what the passenger intentionally shares. Every read and write is logged for accountability. Accessibility and UX details that save time. The page is designed for stress. Large controls, high contrast, and plain language. Works if you have one free hand and 10 seconds. Offline tolerant. If the network blips, we queue your alert and retry. Location prompt is polite but persistent. Sharing coordinates can save minutes of response time. To wrap up, automatic detection covers the events your sensors can confirm. The manual button covers what the human feels, including medical issues or unclear threats. Both push into the same pipeline, both are auditable and reliable, and both ensure we don't miss a call for help in the middle of a storm. In the next segment, Shihana will walk through how these alerts reach responders, what they see on their side, and how operations verify the pipeline during severe weathers. Thank you.
Thank you, Pallavi. Hello, everyone. Today I'll focus on one thing: what leaves our system and how we prove it. When an incident opens, we notify responders. We send one small JSON message. It includes the incident ID, the vehicle ID, the type, the severity, the latitude and longitude, and an exact timestamp. That's it, clear and compact. If the webhook to authorities is available, we send the message there first. That's our primary path. If that webhook is down, we do not drop the alert. We write the same JSON as a single line in our outbox log. That's our backup path. So, two paths, one goal. The message is never lost. Let me say that another way. The webhook is speed and the outbox is certainty. Together, they give us reliable delivery and a solid history. Right now, for testing, we use an echo endpoint. When we send an incident, the echo replies success. That proves the message left our system and reached the outside world. If the echo is not set, we still have the outbox log line. Either way, we can point to the evidence and say, here's what we sent and when. Now let's look at some quick definitions. So we are looking at webhook. What is webhook? It's just a URL we call to say something happened. And what's an outbox log? Well, it's a plain text file. One line per message, time-stamped. Easy to search, easy to backup. Nothing fancy. Now let's look at our heavy rain operations checklist. It's short on purpose. In bad weather, clarity wins. We have 5 checks in total. The first one is the health endpoint. Is the server up? Is the time correct? Are dependencies responding? Good looks like OK with a current timestamp. If health fails, restart the service, then recheck before touching anything else. Second, we have the simulator. Is telemetry flowing? We should see fresh data in the last few seconds. If the simulator stalls, restart it. Confirm new data appears right after. No data means everything downstream goes quiet. Third is incident flow. We expect incidents to appear on the live feed in near real time. In heavy rain, we often see more visibility and lane keeping alerts. If the feed is silent, that is also a signal. Check the inputs are fresh. Check the thresholds are loaded. Fourth is notifications. We want one of two green lights. Either the logs show webhook success or the outbox file shows new lines. If the webhooks fail, do not panic. We rely on the outbox for continuity and escalate to network team. The story is preserved. The network can catch up. And last, we have manual override. If a passenger presses the red button, we should see an incident immediately. If we don't, that's critical. Tell a passenger to call emergency services, record what happened, log the failure with time and vehicle ID. That's the checklist. Now let's have a quick recap. First, we send small, clear JSON files. We deliver by webhook and we always write to the outbox. We use a short 5-term checklist in heavy rain. We apply simply recovery steps when anything fails. We keep the system reliable, explainable, and auditable. That's the core. It's not flashy, it's steady, simple, and safe. Here's the one sentence summary to remember. We send clear messages, we never drop them, and we always keep proof. With that, I'll hand over to Unimaya. She'll show what we store after each incident and how we label the outcomes and how we learn from each case. Thank you.
So thanks, Shihana. And I'm going to talk about what we keep, how we review it, and how that helps us to improve rainy day safety. So we record three kinds of information. So the first one is road telemetry samples. It comes like time, vehicle ID, latitude, longitude, and speed, acceleration, also steering, impact force, and microphone level, and airbag status, and rollover bags. So the second comes the incidents, which is nothing but time, vehicle, location, incident type, severity, and the source of the incident, and a short context window of recent signals. Now comes the third one, which is manual alert, and which comes like time, optional passenger name and contact, location, severity, and notes. So why does this matter? Let's see why does this matter. It's because explainability is a safety feature, right? So when we review an alert, so we can see the exact signal that triggered it. For example, I can tell you like an airbag flag, which is high impact force, indicate a strong collision. So an extreme deceleration with a big speed drop suggests a likely impact even without an airbag. So a sudden stop paired with very loud cabin noise often shows a near miss or a panic event in heavy rain. From a privacy standpoint, the passenger fields are optional. We keep the minimum data that needed to help them. If we spend data to responders, we use secure channels when available. So and we retain only what's necessary for operation and audit. Now let's talk about what we learn from the storms. After a rainy week, we can analyze a few sample questions, which is like where did the rain related incidents cluster on the map? So the events that combine harsh braking and high cabin noise increase compared to the clear weather. So, what was the ratio of automatically detected incidents to manually reported ones? These observations help us to tune thresholds, plan patrols, and improve signage or road treatment where the incidents cluster. So, looking ahead, we have four enhancements on our roadmap. The first one is a live map dashboard. So, the live map dashboard helps the operators can see the incidents at a glance. The second one is integrations for SMS or email board in the notification channels. Third comes a persistent cloud database for long term analytics. And fourth is a machine learning layer that learns from rainy day patterns to reduce false positives while preserving the sensitivity to real danger. Before we close, I want to return to the user experience. In moments of danger, people need one simple action. That's why the passenger page focuses on a single red button. So it's accessible, it's obvious, and it behaves exactly like automatic detection in the backend. Different inputs, same reliable outcome.